So driving home this concept of using the syllabus, in particular the stuff that they ask you that you should be able to specifically describe the formation of these covalent bonds as well as use dot and cross to represent each of these. I'll just very quickly start from the display formula, and by drawing the display formula we can associate hydrogen forming single covalent bond, hydrogen only forms single covalent bond. This is a single covalent bond, so what we could do is we can then convert that into dot and cross. One single covalent bond represents two electrons being shared, and there are no other lone pairs on hydrogen because there's only one outer shell electrons on each hydrogen, and you use it for bonding, and that's nice and happy because hydrogen electrons are in the first shell. The first shell, electron shell, can only accommodate 2 electrons maximum, so that is nice and happy there. Okay, chlorine on the other hand, chlorine is in group 7. So chlorine is in group 7. You can of course also think about fluorine, bromine, as well as iodine because they are in the same group. So if I draw chlorine, I have drawn a single covalent bond because between the two nonmetal atoms, when you get covalent bond, the 7 outer shell electrons of chlorine just need 1 more electrons to go to 8 electron, which is the closest to itself for forming for getting to a noble gas electronic configuration. That's why the halogen typically forms single covalent bond, but it does not mean that they cannot form more than 7 outer shell electrons because chlorine is a third period element, so it can actually have more than 8 electrons in the outer shell. But most of the time, chlorine molecule on its own is definitely a single covalent bond. So I'll draw a single covalent bond as represented by dot and cross, and I'll be extremely wrong because my display formula does not show me the lone pair, but my dot and cross must take into account that chlorine is in group 7, therefore it's got 7 valence electron. It only uses 1 of 7 for forming covalent bond, so I still have 6 more valence electrons on the chlorine. So chlorine has 1, 2, 3, 4, 5, 6, 7. It shares 1 with the other chlorine atom, so it's got 8 electrons in the outer shell of this chlorine. Same deal with the other chlorine atom, except that I draw with the dot. It's nice and easy when you start from display formula correctly, and you can just draw the dot and cross correctly, and that is the way that I would advise you to move forward in this manner. Yeah. The next thing, I'll just jump straight to HCl, which is actually one of the things they mentioned here. Because they mentioned HCl in the syllabus, the associated molecule would have been HF, HBr, and HI. So these are all what you call hydrogen halide, as I said earlier. So the halide would be chloride, fluoride, bromide, and iodide, and all of this is a single covalent bond between hydrogen and the halogen atom. So specifically for HCl, I will draw dot cross Cl, but do not forget, just like the previous example, chlorine is in group 7. It's got 6 outer shell electrons remaining after it uses 1 out of the 7 for forming covalent bond. So that is done, that is done, and that is done. Now I would like to move on to H2O. So oxygen form 2 covalent bond maximum, hydrogen form single covalent bonds due to 1 electron in the outer shell. So oxygen is in group 6, therefore 6 valence electron, 6 plus 2 giving you 8 valence electron. So oxygen form 2 covalent bond. Oxygen uses 2 out of 6 for bonding. You are still left with 4 more. You can count properly, 1, 2, 3, 4, 5, 6 for the cross, and dot on the hydrogen. This is not dot and cross. So to show dot and cross hydrogen, dot cross hydrogen, cross oxygen, cross oxygen. If you like, you can use cross for hydrogen and dot for oxygen. As long as your electron count is good, then that will have been alright. Then there's CH4 and NH3. Perhaps I go to NH3 first. NH3, nitrogen is in group 15, 5 plus 3, therefore 8 electron in the outer shell. Nitrogen group 5. Group 15 is what the A-level students would use. But anyway, So we use the Roman numerals. So 5 plus 3 give you 8. Therefore, you form nitrogen form 3 covalent bonds. I would say usually, because we'll talk about another scenario in another topic in another time. Okay, so there is not dot and cross. This is dot and cross. Each covalent, single covalent bond will represent with 2 electrons in the bond as the bonding electrons, because these are the electrons that form single covalent bond. Okay, so don't forget there is a lone pair on the nitrogen. There is 2 electrons that are not used for bonding, because 1, 2, 3, 4, 5. It's easier to start from the display formula and get the dot and cross. The other one is of course CH4, as I mentioned. Carbon is a very important atom because all of organic chemistry relies on this. Group 4, 4 outer shell electrons. Hydrogen forms single covalent bonds. So altogether we get these 4 single covalent bonds, and you can imagine that the carbon having 4 valence electrons. It shares 4 other electrons from 4 times hydrogen, and therefore the carbon will have 8 valence electron, and that is a completely filled second shell, because second shell is the valence shell for carbon. Of course, you still have the 2 inner shell electrons, but when we form covalent bond or when we form ionic bond or any sort of bonding, it's to do with valence electron. Chemistry is to do with reacting the valence electrons rather than reacting the inner electrons, or rather than reacting the nucleus. We actually only react the outer shell electrons. That is the basis of chemical reactivity. Okay, so what's the other example? We're left with oxygen molecules, CO2 and N2. So I'll do those simple molecules first. CO2, carbon form 4 covalent bond, 1, 2, 3, 4. Oxygen form 2 covalent bond, can be 2 single bonds like this, or can be a double bond like this. And this is very similar to this concept of diatomic oxygen. So there is a oxygen double bond. So there's oxygen cross oxygen. Oops, that is actually wrong. So you have to have dot cross for the oxygen. And don't forget, oxygen is in group 6, so it's got 6 outer shell electrons. It uses 2 out of the 6 electrons, so you're left with 4 non-bonding electrons. So electrons that are not used for bonding, there are 4 left after you use 2 out of the 6 valence electrons for forming 2 covalent bonds. As you see there, 2 covalent bonds, a double bond. So this is kind of similar, but the carbon there form 4 covalent bond, just like carbon here form 4 covalent bond, except that here you have a double bond and a double bond. So you convert that into dot and cross. So if I use cross for carbon, there will be dot for oxygen, and the carbon has 4 outer shell electrons, 1, 2, 3, 4. So there are no more non-bonding electrons. So non-bonding electrons mean the electrons that are not used for bonding, essentially the valence electron, they are not used for bonding. It's all completely used up for carbon, but for oxygen, each oxygen will have 4 more unpaired electrons. 4 more non-bonding electrons. I need to be careful of the word I use. I keep on saying unpaired electrons because that is essentially the term that you will use when you go to A levels. Okay, so in O level you can just be thinking about bonding electrons, non-bonding electrons, non-bonding electrons, bonding electrons. Alright, so the next bit is nitrogen, triple bond, because group 5 outer shell electrons, 1, 2, 3, 4, 5. It forms 3 covalent bonds and share 3 other electrons from the neighboring nitrogen. So there is, if I want to show the difference between the 2 nitrogen electrons, I'll use dot and cross to represent the difference. Cross, dot, nitrogen. Don't forget the lone pair on the nitrogen, because you know how to count number of electrons. All right. So in this last part of the lecture tutorials, just basically summing up the simple molecular structure, or you can call this simple covalent structure, whichever one you like. Just stick with one, but know that they are the same, and Cambridge question can use either these or these. They mean the same thing. Structure is not bonding. That's why it's called structure and bonding. the structure is this, the bonding is going to be covalent bonding. So you need to be very clear on what is structure and what is bonding. Bonding does not have the simple at all, okay? Bonding is just ionic or covalent bonding. The structure must have simple covalent structure, or in the case of ionic bond, then you have giant ionic lattice structure. Giant versus simple are totally different thing. Okay, so in terms of simple molecular solid, discrete mean individual. Okay, so previously you have heard of H2, what else? Cl2, HCl, H2O, NH3, CH4. These are all simple covalent molecules, so they all exist as individual covalent molecules, which of course you can draw them like this, and hopefully you remember, or you can always go back to those lecture tutorials, and you can of course then draw these on your own. Okay, so a simple molecular solid consists of discrete molecules. Discrete meaning individual molecules, so individual molecules held together by weak intermolecular forces of attractions. Intermolecular forces of attraction. Intermolecular, inter means in between, molecular means simple covalent molecules. So this is between molecules. So it's between discrete molecules, between individual molecules. That means these things must have simple molecular structure or simple covalent structure. As you could see here, this is an example of I2 molecules. So the two iodine atoms are bonded together, just like chlorine. Chlorine, because iodine is also a group 7 element. And if iodine is a group 7 element, they don't exist as the atom, because the atom has only 7 outer shell electrons. Instead, they exist as I2, just like Cl2, Br2, I2, you also have F2, because the group 7 elements with 7 outer shell electrons, I can share one of my outer shell electrons with another atom of itself, and then I can get covalent bond. As I mentioned previously, this is now a molecule, but it's not a compound because it consists of the same element. In fact, it's an element because it has only one type of atoms. Okay, so these are all elements. They don't exist as single atom, they exist as molecule, which is like I2. And of course, between the atom, you have this thing called covalent bond, because that is basically what you did in the last lecture tutorial. You show the dot and cross, and here I'm showing it as line, which is basically 2 electrons for every single line. Single line because it shares 1 electron each from each atom, and therefore you get 2 electrons in one covalent bond. Here, between the molecules, you have intermolecular force of attraction. These are weak. Okay, these are weak. They don't have a large amount of energy. They don't need a large amount of energy to break. And that is why you have low melting and boiling point. Low melting and boiling point because you only need very small amount of energy. Or you say little energy. Or you can say small amount of energy. Or you can say not a lot of energy, because you have weak intermolecular forces. You don't break the covalent bond, okay? Not breaking covalent bond, because we are specifically saying that it has low melting and boiling point, and therefore we only need to break weak intermolecular forces. These are covalent bond between the atoms. Intermolecular forces is between the molecules. That means between this and this, between this and this, between this and this. These are intermolecular forces. They require very small amount of energy to break. That's why low melting and boiling point. Just like for ionic compound, we talk about conduction of electricity. When we think about simple molecular solid or simple covalent molecule, they can ask you simple covalent molecule, of which your syllabus specify a couple of these, and you've got to know every single little one stated in the syllabus. H2, Cl2, HCl, H2O, NH3, CH4, whatever they stated in the syllabus. If you don't know, you cannot blame Cambridge, because Cambridge tells you 3 years in advance. These are non-conductor of electricity. No matter whether they are solid, liquid, or aqueous, they just simply do not conduct electricity. They do not conduct electricity, and they want you to explain because there's no free ions or no free electrons to conduct electricity. Question will usually ask you about stating, and question will also ask you on explaining. So state and explain means you gotta state and then explain. So there are two bits to it. If a question simply asks you to state, then you don't need to explain. If a question asks you to explain, then you need to kind of state it before you're able to explain, unless the question has already stated it. This last bit of this lecture tutorial is basically stating two differences between ionic bonding and covalent bonding. They are not asking on compound, they're asking on bonding. All right. So ionic bonding involve ions, which are cations, meaning positive ions, and anions, which are negatively charged ions. Whereas covalent bonding does not involve ions, it only involves atoms. Never ions, not ions. And that is the very reason why covalent compounds, simple covalent compounds, do not conduct electricity. Non-conductor, I can also say, does not or do not conduct electricity. So simple molecules do not conduct electricity, whether they are solid, liquid, or aqueous, unlike ionic compound. Okay, this is asking on bonding, this is not asking you on compound. All right, so the next thing I can think about is the process involved. Ionic bonding involve transfer of electrons. So you are transferring electrons from the metal to the non-metals. So this comes back to your dot and cross diagram from metal atom to non-metal atom, where you did the dot and cross and you show the different electrons going to the anions. Okay, so from metal atom to non-metal atoms. But then what does covalent bonding involve? Covalent bonding involves the sharing of electrons, and there's the big difference from ionic bonding. Covalent bonding involves sharing of electrons, and this is not between ions, it is between atoms. Okay, I have one more difference that I can think of. We talk about what kind of elements will form ionic bonding. Ionic bonding is formed between ion. So ionic bonding exists between when metal and non-metals form bonds. When metals and non-metals combine together to give you a compound, they will involve ionic bonding. Therefore, combine together to give you a compound. Whereas covalent bonding is not between metal and non-metal, but covalent bonding is between non-metal and non-metal. Okay, so when you have non-metal atoms, so when you have all these covalent compound, which I've stated as well, these are all non-metal and non-metal. Non-metal and non-metal, they form covalent bond. 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 Even CO2 molecule, carbon double bond oxygen, carbon double bond oxygen, carbon form 1, 2, 3, 4 covalent bond. Because carbon is in group 4, it's got 4 valence electrons, it shares 4 electrons, 2 from one oxygen, 2 from another oxygen. That's why the formula is CO2. Oxygen form double covalent bonds or 2 covalent bond. Because oxygen is in group 6 with 6 valence electron, it shares 2 more electrons from the carbon, and you need 2 of them, so that each oxygen share 2 electrons there. Basically, counting wise, carbon form 1, 2, 3, 4 covalent bond. Because it's in group 4, it share 4 electrons. Oxygen form 1, 2. This oxygen also form 1, 2 covalent bond. Because oxygen is in group 6, 6 valence electrons, share 2 extra electrons to get up to fully fill out the shell. You can convert this into dot and cross, dot cross, oops, sorry, not dot cross like this. I will draw dot dot cross cross dot dot cross cross. Don't forget that Carbon has 4 outer shell electrons, so carbon is happy. So now the oxygen is happy only if you put in the rest of the non-bonding electrons, and that's how you get dot and cross, as I mentioned plenty of times in the last lecture tutorial. So when you have between non-metal atoms, you have covalent bonding, and ionic bonding exists between metals and non-metals. Ionic bonding, of course, involves ions. That's why the transfer of electrons from metal, losing electrons, and the non-metal atom gaining electrons, and non-metal will form anions. Metals will form cations, and the attraction between cation and anion is what you call ionic bond. Covalent bond involve atoms. It involves sharing of electrons between the non-metal atoms, and I hope you will remember that when you have these, it's actually the nucleus, okay, the nucleus of the two non-metal. They interact like this. These are bonding electrons. These are nucleus, which contain the protons, which are positively charged. They're attracted towards these bonding electrons. That is basically the electrostatic force attraction between the electrons, which are negatively charged, the bonding electrons, which are negatively charged, and the two positive nuclei of the two non-metal atoms. That is the force of attraction called covalent bonding. Alright, that's it really for this lecture tutorial to sum up the bonding topic, which is just to close off and end these lecture tutorials on covalent bonding. If you enjoy my tutorial, so make sure to click the button on the bottom right to subscribe to the channel, and please share the channel widely with all your friends, chat group, study group, whatever group you have, and yeah, your juniors and seniors from school, your relative, and whomever else you think might benefit from this Combined Science 5129 or any other Combined Science curriculum, whether you're in Singapore or some South Asia countries. Even the IGCSE Combined Science syllabus are similar to the O Level Combined Science syllabus, and it will be relevant regardless. Thank you for watching, and follow me at ptet.chemistry, ptet.chemistry on Instagram, Facebook, and Twitter if you use this social media platform. See you in the next lecture tutorials or other tutorials, and thank you for watching and subscribing and sharing the channel.